Today we'll be looking at another question on armature reaction. A 4-pole wave wound motor armature has 880 conductors and delivers 120 ampere. The brushes have been displaced through 3 degrees from the geometrical axis. Calculate A. The demagnetizing ampere turn per pole, the cross magnetizing ampere turn per pole for your B, and your C, the additional field current for neutralizing your demagnetization if the field winding has 1100 turn per pole. Okay, so for this is an important phrase that tells us that our parallel path is what? 2, because of the word what? Wave. If it was lap, we'll be using 4, but wave is always constant 2, but WAP will depend on whatever this pole is. Now, for us to get our A part, we have that our demagnetizing ampere turn per pole is given to us as our mechanical angle all over what? 360 times Z I over what? A. Now, your theta or your angle, which is what? 3 over what? 360 times Z, which is what? Your number of conductors, 880 times your I, which is what? 120 all over your A. Your A being what? 2, because of what? Wave wound. Now impute this in your calculator. You will get your answer to be what? 440 ampere turns. Now, we'll be writing this by the side. A T S is equal to what? Okay, sorry, ATD, not S. ATD is equal to 440. So, moving over to the next one, which is your B. You have that for your cross magnetizing ampere turn per pole. This is ampere turn, that's the meaning of the 80 ampere turn per pole. You have this to be in brackets. The only slight difference between this and your demagnetizing is just the presence of this 1 over 2p and then your minus. Every other thing repeats itself. Your angle over what? 360 multiplied by Z I over A. Now, putting our values, we have that our P is the number of poles, and we are given what? 4 poles, minus our angle, which is what? 3 divided by 360 times Z being what? 880 times I, which is what? 120 all over what? 2. Imputing this in the calculator, we have our answer to be 616 ampere turns. So the unit for your ampere turn actually is actually mmf, that's magnetic force, but the unit is what? In ampere turns. So we have gotten our B part. Now for our C part is demanding for additional field current that neutralize our demagnetization if the field winding has 1100 turn per pole. Now we know that our extra turn per pole is given to us as what? Our ATD per pole all over our current. Now, in case if you're wondering what this extra turn is, our armature reaction, which is as a result of your armature producing flux, similarly your stator or your field magnet is also producing flux. So this flux kind of had a clash or interference, or they kind of have impact on each other. So the impact that is having, that your armature flux is having on your field magnet, we call it your armature reaction. Now it normally represents it in a slanted line, and if we were to find the components of these two components will be A, T, C and A, T, D. And here is our angle that was normally given to us. And as we can see, our ATD is longer than our ATD. That is the reason why in every case your ATC must be bigger than your what? ATD. Because only just a small portion of your armature reaction is what? Your ATD. Now your ATD is countered or is neutralized with the help of extra turn. If you add extra turn to each pole, they will produce more mmf that will counter the one that comes with this one. So that is we want to now this formula tells us that extra turn we are adding to our pole is given to us by that demagnet. This is what we want to counter. We'll be dividing it by what? Current, to find the extra turn we have to add. Well, this time around have given us the extra turn, but we aren't giving what? Current. But we already know what our demagnetizing ampere turn per pole is, which is this. So we'll be making this guy sort of formula. Now making I sort of formula, we have that I is equal to extra, no, have your ATD per pole all over your extra turn per pole, and imputing our values, we have 440 all over extra turn per pole, which is what? 1100. This value given to us here. Now imputing this in the calculator, we have our answer to be 0.4 ampere, because this is what? Current. So thank you and God bless you. So please subscribe to the channel. See you in the next video.